and tell you who I am, how I got where I'm here today, and just I hope it's a conversation. You could interact me, and it could really just be some kind of a sharing of information and path. This is what I got the instruction. I mean, if there's more instruction, let me know. So, so I am Xin San. I'm currently the Associate Lab Director for the Energy Science and Technology Directorate at Oak Ridge National Laboratory. You have heard of Oak Ridge National Lab? Right? Half, right? So Oak Ridge is actually one of the DOE 17 national labs. 17 national labs. So we are the largest Office of Science lab, and we have about 5,800 staff. Annual budget is about $1.4 billion. So I steward one of our 8 science directorates. It's called Energy Science and Technology, where we do all the applied energy research, including grid research, buildings and transportation. So that's where transportation, you know, the marine transportation is part of that as well. And then also yes, manufacturing. So instead of talking about Oak Ridge, I wanted to talk about my path a little bit. So when I got the invitation to come back to Michigan and talk about this stuff, that was, I think, either early this year or end of last year. So I didn't ask what was the format. I was just hoping it's going to be an in-person meeting. And so we're here. So certainly that first part was that. And I also didn't prepare for this venue or this event independently. What happened is last week, it was still March. It was Women's History Month. Department-wide at DOE, we had a Women's History Month celebration, and it was headed by S1, our secretary, Jennifer Granholm, and then we did a panel. So I was part of the panel. I was one of the 4 panelists. The theme is very similar, talking about what led you here, what got you what you're doing now, and what. Also, they were asking like, what was your life challenge or some kind of you know, advice you could give to the next generation engineers. So I didn't prepare slide for this particular event, but I hope this will help. I just on the fly, I changed the title. Some of you might even have noticed that, right? So, but I thought this will also help start this conversation. So me as a person, I'm a first generation immigrant here in the US. In fact, I had lunch with my advisor at University of Michigan here, Dale Carr. He's on leave. So he's my advisor here, and Michigan is really my landing spot to the US. So that was 1991, February the 7th. But I'm a second generation engineer. So both my parents, they used to teach engineering. So my dad used to teach chemical engineering, chemical looping, mass transfer, heat transfer. My mom used to be a professor for non-ferrous metallurgy. They both taught at the Northeastern University in China. And so engineering was not strange to me, but when I was little, I would go to their, safety and stuff were not that stringent at the time. I was allowed to their labs, and that's when I learned strange smells in chemical labs and stuff. So I didn't want to do chemical engineering. but I didn't really know the disparity between gender in engineering college. Like if I look at the audience today, I see 2, 3, maybe with hair, I can't tell. Maybe very, very few representation of female. So when I was in high school, you know, I don't think the gender difference is that much in high school. It's pretty much half boy, half girl. And, you know, I was naturally good at math, and, you know, nobody said that, at least at the time, nobody said that you're not supposed to be good at math, but you're a girl. So and at home, my parents, they would work on these projects, the same projects they would work on, the kind of the university husband and wife team. So I never knew, honestly, in university what was the environment. So when I landed, my undergrad was done at Shanghai Jiao Tong University. So it's about 32 hours by train. So I grew up in northeastern part of China. I took the train when I was 17 and then landed in Shanghai. And then that class of 1990, we had about 120 students in that class. 15 of us were women. So again, I do apologize a little bit. This talk was geared towards like minority engineering, that type of thing. That's when I first started realizing, really in engineering college, female. So it never dawned on me when I was growing up. So from that didn't stop me from just getting myself away from the discipline. Well, when I landed here, well, there's a little story why when I landed in Shanghai, that Naval Architecture Ocean Engineering is the department's name. And how I got there was because high school, when I was in high school, there was Shanghai Jiao Tong University had a recruiting campaign. They gave like 2 scholarships per province. A province is like a state here in China. And I was one of the recipient of the 2 in my province. So when the recruiter asked me, what department do you want to go to? And I just asked him, I asked her, is it her? I said, what is the best department that you have to offer? And she said, it's Naval Architecture Ocean Engineering. And I said, okay, I have to go to the best department. So I landed here without knowing a lot about that department, right? So you will find out in my story, there's a lot of sort of these accidental decisions I made, but in the end, I think it's all fate and destiny. So again, I landed Naval Architecture Ocean Engineering Shanghai, and only after I got there, I found out I was one of the 15 girls in the class. It didn't stop me from trying my best, but then one lesson also after getting there, because of course we were all like number ones in school, our high schools, right? But when we landed there, the university had just had some tragedy happen the summer before we got there in September. Some students early on took their lives and because of depression. So after we got there, we had a training on, look students, you were all number ones in your school, high school. But out here in the class of 120, there's gonna be one number one and you're all gonna be fine. So we had the training then, sort of mental resiliency, finding your place in the class. This is not only about, well, certainly in school we're learning, but this is also about building your network, building your friendship, building your career. It's not only about being number one. So that is what I learned the first thing in Shanghai. Really, it's put yourself in the community, in the place. It's not about being number one, but it's being part of a community. So that's what I learned. In how I chose Michigan. This is another story. This is really interesting because most of you were born after. When I was a year in college, 1987, I decided that I wanted to continue my sophomore year. I started thinking about my graduate, what happens after graduate school. After I graduate, I said I really want to go to grad school. And then what is the grad school, right? Well, I know in China, but I really wanted to come to US. Then there's no computer, right? There's no internet. So how do you find out? So what I did was our school had the best library at the time, donated by a rich person in Hong Kong. This tall 18-story building. So I went to the library. So I camped out. I found out the Department of Naval Architecture and Ocean Engineering. I just went to that index level, right? I look at the papers published in that field. It's really interesting. What I found is, first of all, University of Michigan is really a good school because a lot of papers are published by University of Michigan. But boy, there's this lady, just so prolific. Her name is Ann Arbor. And I really wanted to follow the footsteps of Ann Arbor. This lady was just so smart, and because her name is associated with most of the publications out of Michigan, seriously. So I didn't know Ann Arbor was the city name, honestly. That's how I found University of Michigan. So of course I started to find, there's no Google, right? You couldn't find out. And I mean, I guess if I studied a little more, but the name stuck with me. So I said, well, I want to go to the University of Michigan and be like Ann Arbor. So that's how I chose Ann Arbor. And in addition to Ann Arbor, I also applied to 2 other schools, University of Pennsylvania Math, and also MIT, ocean engineering. So I got admitted to ocean engineering at MIT, no scholarship or no fellowship. I got into no scholarship nor only the Naval offered me RA, it's research. I really had no option. I mean, I couldn't afford a graduate study then. My only choice. I landed in Ann Arbor. I really wanted to be Ann Arbor. And I actually named my daughter Ann Arbor. So if I were to have a son, I was telling my husband if our first child was a boy, I was going to name him Andy, but unfortunately that name was taken by our nephew later on. So my son is named Teddy. So anyways, so after I got here, of course, I under Dr. Carr's advice, I learned a whole lot from him. And then I also got another degree in mechanical engineering from my advisor there is Dr. Jim Barber, and again, learned a whole bunch from him as well. And also Alan Wyman. I don't know if Alan is still here, but several years ago when I was here, I met with Alan as well. Very, very good professors, advisors, and lifelong friends, and also they're just your mentors for life. So that's what I learned from the University of Michigan. So well, not only did I get my degrees, 3 advanced degrees at the University of Michigan, I also met my husband at the same department. It turned out he was from the same school that I was from in China. He was 2 grades higher than me. So he came to Michigan earlier. He came in 1989. I came in 1991 in the winter semester. It turned out we didn't know each other in China, even though we were in the same department. He was, 2 grades older than me, and we never met in China. So we had to travel like 8,000 miles to see each other here. And it's interesting. So we just started dating, and then I remember we got married really quickly because it's not the Chinese culture that you just start living with someone without getting married. So I just wrote my dad a letter. I said, well, Dad, I'm getting married. And he freaked out. He's like, hold on, you should get your degree first, right? Because there is certain image to that, once you get married, you have kids and you'll never have your degree, right? And he just freaked out. I said, don't worry, I'll get my degree. So we got married. And our wedding was done at, actually, it was, the ceremony was officiated by Ann Arbor city judge. It was funny because the city judge had all sorts of other duties to do, right? Not just officiate wedding. So the only time available is the judge. It was on Monday afternoon, I think it's 4:30 or 4 o'clock, May the 20th. And at that time, I had my English as a second language class, an ESL class. So, most people want to skip that class, right? So when they would come up with all sorts of excuses. So I called the professor. I said, well, I'm going to skip your class. She says, for what? I said, well, I'm getting married. And she just chuckled. And she's like, you know what? All these years, this is the best excuse I've ever heard. So I got off that class to get married. So there's my lovely husband. Chan Hai is his name. And he now goes by Kevin. It's a hard Chinese name. And our family picture taken 2 Christmases ago. At the time, we still have our 2 dogs. So 2 kids, 2 dogs. Well, the 2 dogs passed away, unfortunately. Anyways, so that's my family. And that's how I got to Michigan and how I graduated in Michigan. So that's my first. Career. So even when I was at Michigan, people are thinking about what to do after you graduate, right? I just want myself to be versatile. So the process of doing a PhD, I remember the first week after I signed up, Professor Carr asked me, do you want to get a PhD? I said, of course, I want a PhD, right? So we started that PhD plan. In the process of getting that PhD, you take enough classes so you can get another master's degree, right? And we were like, what degree I should get? So we talked with Jim Barber. He says, well, you already get a naval architecture marine engineer, which is good for, mechanics. That we have a very good mechanics program, good mechanics, solid mechanics. And he said, well, if you want to be versatile for the job, you might want to take, because at the time, that department offered one is applied mechanics, the other is mechanical engineering. He said, well, for that matter, you might want to just do mechanical engineering because that will help you. So I did mechanical engineering. Pretty much, to me, I don't really see the difference. And you just go there and take these classes and you get that piece of paper. But the PhD was what I was shooting for, really. So my first job after graduating Michigan, at the time, I was kind of I've been a student for like 9 years, undergrad to grad. Like I didn't stop, didn't do anything. I really wanted to go into industry and really see what engineering is all about. But then my dad keeps whispering to me, you gotta go teach. You gotta go teach because I guess that's how they always view teaching as sort of some kind of a high level of engineering than the real field. So in the back of my mind, I really wanted to do teaching, but then my passion, I really wanted to do real world engineering because I've not done it before, right? You got all these years of education. But at the time, I remember in the early 1990s, mid 1990s, Detroit as the auto industry, I think they just went through some downturn. They were not hiring a lot of people at the time. Then I still want to do engineering. So what I did was I landed in my first job is called Edison Welding Institute. So this is something, it's contract research, is something in between industry and the time if I stay in research, I could go up, go up meaning, you could publish, you could still go to teach in academia. But then if you want to go practice engineering, you still would have those connections at the companies that you work with. So that's why I decided to go to Edison Welding Institute to really as a transition, right? So I stayed there for 3 days short of the year. The reason they hired me was because my skill. So it's interesting with Dr. Carr, what I did was I wrote user material subroutines, Abacus. For Abacus. I don't know if you guys still learn these commercial software. At the time, I was doing ice mechanics research, and we were doing this user material subroutine that we were writing with state variables to model ice, the viscoplasticity, the viscoplastic behavior of ice. So I was pretty good at UMath programming for Abacus, and EWI was hiring for somebody who could do. Went from very cold environment modeling to kind of hot, right, molten metal. So the foundations, the fundamentals are the same, pretty much the same. You're solving partial differential equations. So once I get to EWI, I started working on this stuff. There was a project I could, couple the electrical field, involving electrical, mechanical, and thermal field together. I could write some subroutines to help model resistance spot welding process. So I did that as their internally funded project for about several months. Another interesting story. Again, I'm coming from Barbara Greenfield down to the Buckeye city, right? It was really interesting the first year. There was one project that I went to I was funded on. It's called the Navy Joining Center. So the Navy ships, I think it's called the Arleigh Burke class of destroyers. When you do the welding process, if you don't control the welding distortion really well, these ships came out like skinny horses. You see the distortions coming through these girders, right? So we were tasked to do the welding distortion control project. And I was in charge, there are a bunch of people do experiments. I was in charge to do the modeling and simulations. Of course, when you do welding process simulation, you write these user material subroutines to simulate the thermal expansion and subtract and the contractions during the phase transformation process, and hence you can model the residual stress that is causing the buckling and hence the distortion, right? Thermal tensioning is the technology that we use. Thermal tensioning was actually invented in Russia, but no one had used numerical method of finite elements to predict that to the accuracy where you can actually implement it in a plant. It was always just trial and error. What's the flow rate of the cooling liquids, right? What's the flow rate for, what's the travel speed of your torch? So I came up with the models, a set of conditions. I said, if you weld this plate this big, torch, the Q, which is the flux this much, I said, you will not have distortion and it will come up straight. And these guys in the welding shop didn't believe me. We had a bet. So this on the floor, the engineer, I still remember his name, Chris Arnold. He later on becomes some director somewhere. He's OSU grad. He didn't believe me, and we bet a case of beer. And I don't even drink beer. I can't. I'm allergic to sulfites. So I said, okay, a case of beer. Guess what? My conditions worked. And that was the first time in real time a model-driven prediction actually guided experimental establishment of welding without distortion, right? Till today, I haven't seen my case of beer. Okay. Don't bet with a no. Ohio. You will not get your beer. Anyways, so that's a lessons learned. So that's at EWI, right? 3 days short of a year that I get my anniversary, I actually left EWI. I was actually recruited by a current faculty here, Dr. Ping Shandong. I don't know, some of you may have taken these classes. At the time, he was the manager at Battelle. Battelle is the largest not-for-profit private research institution. I'll get back to Battelle later. So he recruited me because Battelle had just landed the ATP project. ATP is Advanced Technology Program, I think, out of NIST. The thing is called IRW, Intelligent Resistance Welding Project. The idea is, resistant weld, if you look around, if you ever fly, if you see these, well, I guess fly is more rivets, but cars, if you take the car, I think they don't want you to see, but if you put your hand in the door seam a little bit, you will feel these welds. Essentially, it's you pass the current through 2 sheets of metal, and resistive heating would melt the metal at the interface, and then that creates the bonding, right? Essentially, it's a fusion weld, but you don't see. Hopefully, you don't see the sparks. So, Keisha recruited me because I wrote these user material subroutines to do the welding process simulation. So I went to Battelle. Well, in between, even I went to Battelle. They gave me an offer. I remember they interviewed me. They gave me an offer. I almost signed up, and then I found out that I was pregnant with my first child. I wasn't gonna go to really sign up with a company, and all of a sudden I'll be, 8-9 months later I'll be on a maternity leave, right? And plus at EWI, they already signed up. They already approved for foreign travel that I had with you know, when you're young, you really want to explore the world. I wanted to go to Rio de Janeiro. There was an international conference, and you know, so when Battelle gave me the offer with these two things lingering, I went to Battelle. You know, I still remember the manager was Dave Snedeker. I just went into Dave's office. I said, well, Dave, thank you for the offer, but I'm not coming. Why not? I thought things went well. And I told him, I said, you know, this part of the lessons is how I got here is sometimes someone else's response in a split second could change your mind on what you do for your career. So if they would have slowed down and just start a conversation, then perhaps I wouldn't be here today. What Dave did, I think it's just, he's instinct. He didn't plan on this, he didn't know that. His eyes just opened up and he's just so happy. So congratulations. And Battelle is all about family. And you know, so honestly, I didn't expect that. I thought I was there just to say no, thank you, right? But his split-second reaction really changed my mind. I was like, wow, this is a family-friendly place, right? You know, because honestly, if I were the manager, perhaps I wouldn't have said that because let's just be honest, in the mid-90s, right? Honestly, Dave Snedeker's reaction changed my attitude. I thought I was going to go in there and say, thank you very much, I'm not coming, but then on the spot, I said, okay, I'm coming. So I ended up in Battelle. May the 6th is when I signed up with Battelle. I stayed 8 years at Battelle Columbus. And those 8 years, I had 2 kids. I guess I did what I could have done to sort of stay well being the consultant, you know, do these work. I had to travel a lot being in Battelle, right? You know, we do the automotive related research. Pretty much we would travel to Detroit in a 1-day trip, get up 6 o'clock, start driving, get to Detroit at 9, and do a whole day business and leave Detroit at 5 or 6 and get home at 9. So that was pretty much it, right? Very busy, of course, you know, raising 2 kids. I didn't publish a whole lot. I really didn't. I think I counted by the time I got 2004, I got to PNNL, I had like maybe less than 20 journal articles, maybe 19 or 20-ish, right? Let alone H-index. H-index is kind of a lagging indicator. So, but you know, retrospectively, I regret that, you know, I had 2 kids and I had to do these. But you know, under the stress at the time, you really try to do a whole lot. You know, you try to be a good mother. I tried to be a good mother, which I at times thought I was failing. I was trying to be a good engineer. I did what I could do at the engineering level, but I didn't excel. You publishing, you do all these above and beyond. You'd be going out to professional societies, volunteer your time. Didn't want that because I had to be a mother. Just be honest, right? And that's my choice. I don't think I regret, but that's just how it worked out. So about 2000-ish, I started working with the lab called Pacific Northwest National Lab because of my, again, UMAT ability. Now at this time is modeling of automotive windshield. They were trying to look at somebody who could do predictions of brittle materials. Guess who? I did ice, right? So they came up with me. And that was a DOE funded project on lightweighting of vehicle windshield. So I started working with the lab out west, and pretty soon, I mean, I started really building a really good relationship with that lab. So Battelle, in addition to doing research and contract research, they also have a lab operations department. They actually manage, maybe right now it has grown 7 or 8 national labs right now. They used to manage PNNL, Pacific Northwest National Lab, solely manage PNNL. They also solely manage NREL, National Renewable Energy Lab. At one point, I think they also have Battelle Geneva, Battelle Europe, all these things. Now I think they manage a whole lot of other ones like ORNL since 2000. And then I think Los Alamos, recent addition. So anyways, So Battelle has a very big presence in the DOE world. So I started 2000 working with them. By 2004, there was in the middle, there was a downturn. Remember my husband, the person who I got married right here, he graduated about a year ahead of me. So he went to work at ABS, American Bureau of Shipping in New Jersey. And, of course, after I graduated, it's difficult for me to, well, I guess I could have gone to ABS, but I didn't want to work for the same company. So then if you don't want to work in ABS in New Jersey, then there's very limited for what you can do with a welding background, well, with a naval architecture background. So that's why I ended up in Ohio, and he ended up coming from New Jersey to Ohio. Luckily for him, he switched field a little bit. He now was doing, like, he did fluid dynamics here under Dr. Armin Chosh. And so for him, it was easy to switch to just programming, computing. So he was programming for the thing called the Safe Hall out of ABS. So, and then he was able to move to Lucent Technologies at the time in New Jersey. So Lucent also has a presence in Columbus, Ohio. It's not a flat transfer, but pretty much it helped him getting the job in Lucent Technologies in Columbus, Ohio. So remember then there's also a dot-com bust in the early 2000s, right? Lucent was downsizing their domestic jobs, and his department was basically told you either had to move to overseas. At the time it was China, or basically you're just gonna get laid off. So we chose to stay. Of course, I have a job here. He chose to stay, but also because I was working for the DOE labs at that time. I've been working with the DOE labs for 4 years, and they always wanted us to go out there, so to recruit. But one person is easy. I can go there in a heartbeat, but for us as a family to move out there, we have a second body problem. So we were never motivated, because you have 2 jobs in Columbus, why do you move, right? So when Lucent decided downsizing, that was a perfect opportunity for us to really just move. So we were able to find him a job at PNNL, so we moved 2004 to PNNL. So really the story here is a lot of things just happen, right? In life, you can't really optimize to the best. Just do what your heart leads you. And I think planning is good. Having ambitions are all very, very good, but you just sometimes you just have to take your gut and then go with it. So really, it's at PNNL that I grew up my career and my reputation. I landed at PNNL myself, one person, in about, let's see, 2009. 2009, I had a team. I grew the program, had a team about 10 to 11 people, and then we have to have a representation because we're paying taxes, right? So I created a team called Computational Engineering Group. Again, I think by the time we landed in PNNL, we had our kids. I mean, kids grow like weeds. They don't need you always, right? So they went to school, kindergarten, so I could focus a lot on my career. So I started publishing. I think at PNNL, I started picking up my publications. I started growing my sphere of influence, hiring people, hiring colleagues, and external network. So by 2013, that'll be 9 years into PNNL, I was promoted to be the highest rank in PNNL's technical ladder. It's called the Laboratory Fellow. So 2013 and then 2017, I got recruited to Oak Ridge National Lab. Now these national labs, they do recruit back and forth, right? So we would be recruiting from PNNL, they would be recruiting from Oak Ridge. So it's all fair game because it's one big family. So when I was recruited there, I was there I joined ORNL as a division director, 2017. So now almost 5 years ago. When I landed there, the division was 150 people. So in about less than 3 years, in about 2029 in the fall, I counted, we hired about 150 people. So we almost doubled the size of the division. And 2020, I think March, we started the lockdown. February was the last trip I made. And then 2020 in May, our lab director wanted to reorganize the laboratory. So when they look at the sizes of these different organizations, certainly my organization grew quite a bit. And it was not a directorate by itself yet. The lab director, this is foresight. So he told me to reimagine the organization. What do you want to do? Starting from clean sheet of paper. So this is again before the election. This is June of 2020. I said we want to do clean energy, not just clean energy, but decarbonization. So the new organization, we organized completely around decarbonize the economy. So I now have 3 divisions. Like I said earlier, electrification and grid infrastructure, and then buildings and transportation, and then manufacturing. So if you look at buildings and transportation, those 2 sectors consume about 70% of raw energy, and manufacturing consume about 30% of raw energy. So we take a lot of pride in doing that, not knowing the political outcome, but we see this as a technology challenge for the nation. So after we stood up the directorate, again, everything is fair and square. We have to compete for the job. So I competed for the job, and I got officially selected to be the ALD Associate Lab Director March 1st of last year. So that's how I got here as far as journey wise. And I think the next slide is just career advice. This is my last slide, by the way. Life challenges. So this forum, the DOE forum, they wanted to have, minority staff members talk about what's their life challenge. I consider myself as really lucky to be where I'm at. I say this because I didn't grow up in a family where I'm the first generation college grad, or I can't claim that. My parents both went to college, and they actually ended up pretty well. But what I think what they taught me, or what they didn't say to me, I think played the most important role. What they never had implied to me, that just because I'm a girl, I'm a female, I couldn't do anything. I couldn't do like certain things, right? I could remember growing up, I have a doll or 2, but most times I was helping my dad. He was an amateur carpenter. I would be his little apprentice. He would be making things like, hand me this, and I'll just do this. And hand me that, and I'll just do that. It never dawned to me I could do that. I guess it's part of it is what you don't say to certain people, right? Because they never told me I couldn't do this. I mean, it's just natural. I love engineering. I'm really good with my hands. Even today, I love to do things with my hands. So it's like, life challenges. What is my life challenge? So I started thinking back. I guess to me, a life challenge is really about work-life balance. When I was early career, I mentioned to you when I was early career, I had to travel a lot, to the point where I really didn't think I was doing well, either being a mother or being a good engineer. I mean, it's like, what do you do, right? And at one point, it was later career, and I'll talk about it, life balance. You just feel like you can't switch roles very effectively. So I think when I was at Battelle, I didn't tell this to many people. I almost start thinking quitting engineering, because I felt, I can't see myself do this throughout my life, right? Because when the kids were little, you can't imagine them growing up, not needing you, right? This is just my mode of life, just screaming kids and demanding job. I thought I could do this for the rest of my career, right? I honestly started thinking of quitting. I took the LSAT. I almost went to law school. I thought law would be better. I don't know why. But I didn't do it. I didn't pull the trigger. So I guess I toughed through. But now retrospectively thinking, I was not approaching it the right way. Right? You just have to put things in perspective and do the best you can, and not compete with. Because I was thinking, competing with the full-time moms. Oh gosh, their kids go to all these stuff. Mine don't. And at times my little girl will be crying, be the last one to be picked up at daycare, and all these other moms. So, I guess one thing is kids grow up. The second is, I guess, just don't compete. Compete on your own timeline, set your own priorities. Don't compete with other people. Everybody's situation is different. That's all I could think of as far as work-life balance challenges. Later stage, I also had one challenge that I think it's worth sharing is that, so this is 2016 in the spring. So my father, after he retired, he came to live with us in the US. But he was diagnosed with brain cancer 2015. And the prognostics was not very good, and the doctor said 15 months, right? So, and there at that juncture of life, I have a very demanding job as a lab fellow, as a investigator at PNL, and I 2 kids in high school. They're also going through like puberty, really, kind of just rebellious, I guess. And then my dad was terminally ill, and you got to take care of what you got to take care of, right? So these chemotherapies, these surgeries, I went, but it was funny because at one time DOE was doing this women in DOE video tapes, right? And they don't have you rehearse or anything, so they just sent a bunch of two guys just taking recordings in front of the building, they talk about all these things, mission or what you do. That's all great, right? Their last question is, what do you do in your spare time? Honestly, at that question, I cried in front of the camera. Spare time? Excuse me? What do I do in my spare time? Oh gosh, I think they edited it out. But the thing is, really, I just think it's about prioritization. It's not about you make other people happy. It's about making yourself happy. And retrospectively, I don't regret spending the time taking care of my dad. I don't regret taking care of my kids when they were little. I don't regret that maybe my career took 5 years, delayed to be successful. It's okay. I just, maybe it's my age. I'm coming to the stage. I was telling Dale earlier today. I said, well, if they want storytelling, I'm getting to the age where I really love telling stories. This is a sign of getting old. So I guess that's it. And I guess one other lessons learned or something I could share with you is never stop learning. Never say no to new opportunities. There's a lot of stories. So this story also, so carbon capture. How many of us know what is carbon capture? Well, because we don't do it here in this department, right? So it's interesting. 2009, we were taking family vacations to Yellowstone National Park, driving the van right past Missoula. I got a call from my manager. He says, Jen, you got a call on this conference call tomorrow. I said, for what? I'm on vacation. He says, carbon capture. This meeting is physically happening in Chicago, but since you're on vacation, you got to call in. And I said, well, I know nothing about carbon capture. Well, this manager of mine, it's another day of story, so I won't go into details today. He wouldn't take no for an answer. When he says something, you gotta do it. So I said, okay, I'll do it. So it turned out Yellowstone, if you've gone into Yellowstone as a park, there's no Wi-Fi, right? So you can't call. There's no data, you can't call. So I had to take 2 days of vacation out of my vacation. I had camped out at the resort while they went to the park. So that was actually the kickoff meeting for the DOE's initiative on carbon capture simulation initiative. So it's funny because at the time, I knew nothing about carbon capture. And I freaked out, right? You gotta prepare. What are you gonna say? This is a kickoff meeting. So luckily my dad was in the car, and he was a professor in chemical engineering, right? He said, don't worry. It's all about mass transfer, heat transfer, bubbling fluid. So he gave me a crash course in the car. So And he was right. The fundamentals are the same. You're solving the same Navier-Stokes equation, honestly. For those of you who do fluids, right? You're solving the same partial differential equations, except just with different parameters in front, right? So don't freak out on things that you have not been taught in school. I would argue what you learn here is critical thinking skills. Okay? So I mean, I started learning carbon capture. I'm not an expert, but I am leading a lot of carbon capture work at the department and also at the laboratory. So, and carbon capture is becoming very, very important in today when we're trying to decarbonize the economy and the industry. So again, my lessons learned, if I were, honestly, if I were to say no that day, I wouldn't be here because carbon capture is one of the capabilities that I brought to Oak Ridge. We started building, when I landed at Oak Ridge National Lab, we had 0 project on carbon capture. Right? Now we have a section of people doing that and millions of funding per year. So I guess that lessons learned is just don't say no and have confidence in yourself and have the ambition to make a difference. And what you learn here in school, again, it's not about you memorize this equation and you know how to, what exactly the number is. It's about, foundations of how to do critical thinking. So don't ever say no to a new learning opportunity. And don't always think that you can learn it from school. You can learn a lot on the job. So I guess that's what I learned. And is that 12:56? I have a lot more stories to tell, but I think for the time being.
2 questions. Is your daughter's name really Ann Arbor?
Annie.
Annie, okay. And did either of your children follow into your footsteps in engineering?
Not on my side, but my 2 nieces are both Michigan engineers.
Oh, great.
In fact, the one that's still here, she is a software. Yeah.
When did you finally realize Ann Arbor was a city?
Oh. Years before I came up here. Yeah. But hey, those accidental discoveries, right? I thought I'd share that with you because I didn't share it with many people. That would sound too stupid, right? But literally, how do you know in the mid-80s? Literally,
Oh, yeah.
in the 1980s, you can Google, right? I was on the other side of the globe. And
I think it's an awesome story.
How was the Zener balance back in 1991? Was it as bad as it is right now? I mean, can it be bad? Worse? Were you the only one?
I was not the only one. Professor, I'm still in contact with her. She's doing a ERC. She's in, I guess she's in EATS. Anna Stefanopoulos. She was one of us. She was upstairs. Our graduate office was upstairs in that corner. I don't know if we changed or not. She, and then there's another lady, Alan. What's her name? Alan. What's the insurance company?
Aruda?
No, Alan. No. There's a, so our suspicion was that her dad was like really wealthy, the insurance people, right? But she quit because she was very bitter with her dad at the time. I can't remember. This is 3 of us.
Okay, 3.
In PhD program.
A lot.
But I think Anna switched to Berkeley. Anna switched. She went under Parsons to do combustion controls, I think. Then she went from bidding controls to Berkeley. She got her degree or something at Berkeley, and then she came back because you can't get a
You're a
PhD.
professor in aerospace.
Yeah, I know. I'm still aerospace. I'm still.
Are you talking about Anastasia Stefanopoulou or?
Stephanopoulos.
Yeah. Yeah, okay. Yeah, I think she's in aerospace.
She's mechanical.
Or, yeah.
Yeah. We're still
Trying to find
collaborating
it,
on the
like-
CRC that she's writing. A lot of fascinating stories about early stage. I think Professor Tony Wass is back, right? In Arrow.
Yeah, director.
I took his first class ever here at the University of Chester. It was just awesome. It was so funny. I don't know if he still teaches the same style, right? He came into the classroom with a pair of slippers and he's like, if I were born 200 years ago, I would have been moving. Because it's like all these big stuff had been invented, it's just, he's awesome. I kept in touch with most of my favorite professors. So when he was at University of Washington, I was at Naval, we visited and stuff, right? And then Dale, of course, every time I come, I talk with Dale, and whenever we have a chance, we visit with, when the family comes back, we visit with Dr. Chosh. Alumna, just so you got some awesome professors here in UNM. And I remember when he was teaching 517 physical plasticity, he would use his tissue as the example. That's just some awesome professors. And Jim Barber, that course elasticity was so dry. I mean, if it was taught by other professors, I think it would be bad. But honestly, I took that class, and at one point when I was a kid, that little town had the WSU, Washington State University, Tri-Cities campus. For some reason, their elasticity course was taught by this 80-year-old guy. I mean, it's a small branch campus, right? It was this 80-year-old guy, and for some reason, this guy just passed away suddenly, and they all of a sudden they needed somebody to teach elasticity, and they were just begging for people to teach elasticity. I was like, I can do it because it was fun. So I volunteered to teach that one semester. It was fun. It was fun to go back and derive those little integrals. And honestly, to me, it's just elegance. In real time, in real world engineering, you may not have that elegance, but in course teaching, you can really see that elegance. Sorry I mumbled, but oh yes.
Pros and cons of working at national labs.
Lots of pros. Gosh, if you guys want to join us, we are recruiting. So again, I would say pros and cons of pros. We are again in the middle. Remember, I was talking about going to academia or going to industry. You're still in the middle. I guess the theme of my story is after 32 years of really soul searching and trying to find myself, I'm still there. I didn't go to industry nor academia. I'm still there, right? I'm still doing contract research. So it allows you that flexibility. Also, the pros is that you have the ability to do big team science, not a single PI science. So the big difference between a lab and a university, to me, after kind of seeing both sides, is at the lab, typically we do big budget projects of national significance, I would say, right now, decarbonization. It really involves and demands the entire college of engineering, the domains. In addition to that, is the math and computer science. So it's that scale of a project is hard to be pulled together at the university level, because here it's, every professor, every PI is really their own expertise in their own domain, right? But at the national lab, I could use one charge code, essentially one project, right? We rally the entire college for something important. So that's the pros. Yes. And cons, you don't want to get on cons. But also another pro is we have a pension. We are the very few in the US that could carry a 401k and a pension. So the pay is very, very competitive. If any of you are interested in finding your career in the national lab area, let me know. We are actively recruiting. I didn't bore you to that. So I remember one of those, I remember whatever it was hot in the basement here, and it was dark with view graphs. We were just like hard to keep up. Thank you for your attention, for coming, and again, if you need advice, talk to me, or not to hook you up with whoever you like to talk with. And we have a big network of Patel Labs, and a lot of these other national lab directors are people that graduated from Woodbridge, right? So Berkeley, Los Alamos, and Naval. So we have graduated a lot of lab directors. Ever want to, not just at Oregon, if you want to work at the National Lab System, we should be helped.
Thank you.